So the big picture for this lesson is the factor theorem. The factor theorem says that a polynomial f of x has a factor of x minus k if and only if f of k equals 0. So I'm going to write some of that down. So f of x has a factor of x minus k if and only if f of k equals 0. So what does that mean? I have an example here all ready to explain all this. So if I have the polynomial f of x equals 2x to the third power minus 9x squared plus 7x plus 6. So for example, if f of 2 equals 0, then x minus 2 has to be a factor. And you could try any input you want, but if the output comes out to be 0, then you found a factor. And let me go ahead and show you. I'm going to use synthetic substitution to evaluate the function because I just like it better. So I'm going to list the coefficients: 2, -9, 7, 6. Put the 2 right there that I'm doing the input. Bring down the 2. 2 times 2 is 4. Add to get -5. -5 times 2 is -10. Add to get -3. -3 times 2 is -6. Add to get 0. My remainder is 0. That means this divided in evenly, and when something divides evenly, it is a factor. So this is the constant term, this is the x, and this is the x squared. So that means I found one factor, x minus 2, and then I have 2x squared minus 5x minus 3 left over. That's from the quotient here. So now what I can do to continue factoring is I can factor this trinomial here, and that's factored by grouping. So multiply the 2 times the -3, that makes -6. Factors of -6 that add to make -5, that's pretty easy, -6, +1. So then I can do my factoring. So what's in common? 2x squared and -6x. The 2x is in common, that leaves x minus 3. And then plus, and then I have kind of an invisible 1 factor here, and then x minus 3. So then to group, you have 2x, and then plus the invisible 1, plus 1, and then x minus 3. Okay, so those are my other two factors. Now I combine it with this one over here, and that makes my factored polynomial. F of x equals x minus 2 times 2x plus 1 times x minus 3. Okay, so that is how you can use the factor theorem. You can input a number into the function, and if you get a remainder 0, that tells you you have a factor. And you can use synthetic substitution if you want. Now let's talk about the rational zero theorem. So you're able to factor polynomials in that last lesson because you were given one of the zeros. But what if you weren't? What if you have to figure it out by yourself? Well, you wouldn't want to just sit there all day doing all kinds of possible numbers. There are just too many. But what if you could narrow it down a little bit? Well, that's where the rational zero theorem comes in. The rational zero theorem says for any polynomial function, every rational zero will have the following form. It'll be a factor of the constant term divided by factor of the leading coefficient. Let me use this polynomial function as an example. So here's how you list them all. Factors of the constant term. Well, the constant term is 6. So that is 6, 3, 2, 1. Factors of the leading coefficient. Well, the leading coefficient is 2, so it could be 2 or 1. So these are all possible factors when you divide them. So in other words, 6 divided by 2 is one possible factor. And by the way, these factors can be positive or negative, so you need to put plus or minus in front of the possible factor list. Next is 3 divided by 2, plus or minus that. Plus or minus 2 divided by 2, plus or minus 1 divided by 2. So that takes care of these. Now we have to do the other list with the 1 as the denominator. So plus or minus 6 over 1 plus or minus 3 over 1, plus or minus 2 over 1, plus or minus 1 over 1. So any of these are possible factors, and some of them can be reduced. So let's do that. Plus or minus 6 divided by 2, that's plus or minus 3. Plus or minus 3 halves, that cannot be reduced. Plus or minus 2 over 2, that's plus or minus 1. Then plus or minus 1 half. And then plus or minus 6 over 1, that's plus or minus 6. Plus or minus 3 over 1 is plus or minus 3. Plus or minus 2 over 1, well, that's plus or minus 2. And then plus or minus 1 over 1, plus or minus 1. Some of these are repeats. Plus or minus 3 is in here twice. Plus or minus 1 is in here twice. So my final list would be all of these and then this. So if they're rational zeros, they're going to be these numbers. So that's 2, 4, 6, 8, 10, 12, 14 possibilities. Well, 14 possibilities seems like a lot, but it's much better than not knowing any. And you can also use a graphing calculator to help because you can graph the function to estimate which zeros you should try first. And just to verify this, I already worked this out, and I found the zeros were 2, 3, negative 1 half. And that's because we had already factored in the last lesson to get f of x equals x minus 2 times x minus 3 times 2x plus 1. And that's how you get these zeros from the factors. So all of these fit on the list. 2 is on the list right here, plus 2. 3 is on the list, plus 3. Negative 1 half, that is on the list, negative 1 half. So this is just a way to make finding the factors and finding the zeros easier. And you'll see a lot of examples in the lesson. That's the big picture.